Who doesn't love rainy season, right? Like dancing in the rain, slow dancing in the rain, or just the sound that makes us feel so happy, or the smell that comes afterwards. It's called petrichor, by the way. Whatever, it's beyond expressing these feelings with some words or phrases, right? As we all love rainy season, let's play a game. I want you to draw a raindrop. You'll have only 5 seconds to finish it. So let's do it, okay? Your time starts now. Time's up. Now, let me tell you something else. If your raindrop looks like this, then you are wrong. The shape of the raindrop doesn't look like this at all. Here's why. The raindrops are more like spherical shaped. And the reason behind these is surface tension. Now, water has a high surface tension compared to other liquids due to hydrogen bonding. Due to surface tension, the water tries to minimize its surface area. And while the sphere has the smallest surface area among all the surfaces enclosed by a given volume, and well vice versa. To understand why, please click here. You'll get an idea. When raindrops fall through the air, the gravity pulls it downwards, and the air exerts an opposite force upwards. And now, this is actually air resistance. This results in a distorted spherical shape, much like a hamburger. Or is it? Now consider this. If we observe a water drop in zero gravity environment, then we can see that it's perfectly spherical. Why? Because, well, there is no gravity, there is no air resistance, there is only surface tension at its work. That's why. But why? Right? Why? Why does the surface tension make it spherical? Right? Well, remember playing that game where we used to hold each other's hands and start circling around. Now increase the number of people in this group and start circling. You will find you all have created a circle. Why? As all of you are pulling each other inside against the centrifugal force, which is trying to push you outwards, and its net force is creating a circle. Same happens with surface tension. Well, the only difference is here it's only water molecules that are pulling each other inside, and there is no centrifugal force or anything else like that. So what about the Earth? Aren't you gonna find any spherical shaped raindrops? Of course we can. But here's the catch. The surface tension of the water droplet needs to be larger than the air resistance. For air droplets smaller than 1 millimeter, the size is spherical, as the cohesive force, the force in between two water molecules, or in between water molecules actually, is higher than the air resistance. Now that's why there is not much to do for the air resistance against that surface tension. That's why it's spherical. So as this small droplet falls through the air, it catches other small droplets too, creating a bigger one. Now, at about 2 millimeters, the air resistance starts to deform its spherical shape. It's more like flatten out at the bottom. At about 3 millimeters, the raindrop looks like a hamburger. As it gets bigger and bigger, the air resistance also becomes stronger and stronger and stronger until it overcomes the surface tension of that raindrop. And that raindrop, I mean the big one, then splits into many smaller raindrops. But before splitting into smaller droplets, it actually looks like a pancake shaped thing, which then becomes a parachute shaped thing, then splits into many smaller droplets. So is there a limit, like how big a raindrop can become? Well, the largest recorded raindrop was about 8.6 millimeters, and they have been detected using a laser instrument on 2 different occasions. One was in Brazil, September 1995, and July 1999 in Marshall Islands. But without these spatial cases, the most common size is like 5 millimeters, and after that it actually splits into many smaller water droplets. So the shapes of the raindrop, well, it's spherical, then weird spherical, then like a hamburger, then pancake shaped, well, then comes the parachute shaped raindrop, but never ever a tear shaped one. It's not possible at all. You might say, but I saw a tear shaped drop when it fell from the tap. About to fall, to be exact, from the tap. Well, that time it was held behind by a static source, meaning the tap wasn't moving at all, and also there was adhesive force, the force in between 2 different kind of molecules, between the tap and the tap surface and the water molecule. And the same goes for tear drops as well. There is an adhesive force in between the skin surface and the tear molecules. But for a free-falling raindrop, there is no force such that. I mean, nothing is holding it back. So it's not tear-shaped in any ways. Thanks for watching. And don't forget to click on the subscribe button and the bell icon, definitely. Please like and share. Happy knowledging.